All right, good morning for me. Um, Chapter 3 recap. What do you need to know about derivatives? It's going to be a quick video and hopefully we'll cover everything, and I'll just reference the section in the book. I'm not going to do any examples, so if there's anything you want to review, go back through your notes, go back through the old videos, go back through the book, and you should be able to find it. So first of all, what is a derivative? Well, derivative is just another word for slope or instantaneous rate of change. And that really is the key to this whole thing. And you've already know how to find that instantaneous rate of change, but we're going to sort of redefine some things and then practice it more. Sorry about the handwriting. I haven't done this in a while. So we know that slope, instantaneous rate of change derivative, the limit as h goes to 0 of f of a plus h minus f of a divided by h. And the notation we're going to use for derivative given the function f of x is f prime of x. That little prime thing right there. Right there, that's the prime notation. And so let's see, what's the alternative definition? The second definition, f prime of x, is the limit as x goes to a of f of x minus f of a divided by x minus a. And as I mentioned previously in earlier videos, the choice of which to use is just situational. Sometimes one's going to work better, sometimes the other's going to work better. We should be familiar with graphing of derivatives. If we're given a graph of a derivative, we should be able to go back to predict an original graph. If we're given a function, we should be able to graph the derivative by estimating slopes. Or calculating for that matter. And if we are given data, we should be able to find derivative just by averaging points. We just take take 2 points, find the rate of change between them, plot that, and just keep doing that for all the points in the data set. And finally, we can have one-sided derivatives, because a one-sided derivative, if I'm approaching a, I can take the limit as x approaches a from above or from the right. And if I'm approaching b, I can take the limit as x approaches a b from the left. So one-sided limits can exist in situations where a function is ending or has a discontinuity. All right, 3.2, what do you need to know from 3.2? The title is differentiability, and as the title implies, we're making decisions as to whether a function is differentiable. Reasons it wouldn't be differentiable: you should be able to identify a corner, a cusp, and notice that the limit goes to infinity on both these, positive or negative infinity on both sides. A vertical tangent, where you have a function where the tangent right there is vertical. Tangent vertical, that's weird. There's no I right there. That's an R. Vertical tangent, and then of course a jump discontinuity, where you go from one place to another. And again, we're dealing with in the domain. If a function is not defined in a particular value of x, well, then we can talk about a discontinuity, but we don't say it's not differentiable, because then every function that doesn't have an infinite domain would be non-differentiable. Okay, what else about differentiability? If a function is differentiable, differentiability implies local linearity. You saw that in the example. Um, if we're trying to find the slope at some point, if I zoom in, eventually, if I zoom in far enough, this will just look like a line. It isn't, of course, but it will look like a line. Numerical derivatives on the calculator. Remember that a numerical derivative is an approximation. And be careful with numerical derivatives because you can be fooled. Remember that the numerical derivative in your calculator basically is taking a point just above minus a point just below. Divide that by the distance between them. And you can be fooled because, for example, your point just above and your point just below could be there, slope of 0, but of course we can see that that's non-differentiable. And then finally in this section, if a function is differentiable, I'm really tired of writing differentiability, so I'm not going to, implies continuity. If a function is differentiable, then it must be continuous at that point. The converse is not true. And again, we look at corners or cusps. That is continuous, but is not differentiable. All right, 3.3, the rules. Derivative of a constant. I'm not going to replicate all the rules, but there's the constant multiplier. There's the power rule. And let me just make a list of. There's the sum and product rule. You should be familiar with all these. And there's the constant rule, derivative of a constant. And this is the derivative of each of these. So go back and make sure you're familiar, you know these. The important ones, the ones that are more difficult. The product rule, UDV plus VDU, is like how I abbreviate it to remember it more easily. And the quotient rule is VDU minus UDV, and order matters because you're one positive, one subtracting. Saw a problem just the other day where somebody had them in the reverse order, and of course you just get the negative of whatever your answer should be. So yes, you really need to know all those. Let's see. Horizontal tangents. Horizontal tangents. How do you find a horizontal tangent? Well, obviously anything that is horizontal has a slope of 0. So you find the derivative. You set it to 0. You solve, and that will tell you where the horizontal tangents can be found. Moving on to 3.4, velocity and other rates of change. You've got position, velocity, acceleration, and jerk. Velocity is the rate of change of position. We take the derivative with respect to time. Acceleration is the rate of change of velocity. We take the derivative with respect to time. And jerk is the rate of change of acceleration with respect to time. We take the derivative. A few quick definitions for motion. Displacement is change in position. Change in position. And so we have to remember that it's S of A minus S of 0. You have to subtract where you started. Average velocity, obviously, is just how far did you go divided by how long did it take you to get there. Instantaneous velocity, well, anytime you see the word instantaneous, you're talking about a derivative. The limit is delta t goes to 0 of S of t plus delta t. minus s of t divided by the change in time. And finally, speed is the absolute value of velocity. Velocity has direction, speed does not. There's a reason they call it a speedometer in your car and not a velocityometer in your car. Free fall constants, you should know them. They never change. Gravity on Earth is 32 feet per second squared, or 9.8 meters per second squared. Do you need to know them for this purpose? No. Should you just know them generally? Yes. All right, let's move on to marginals. Margin. The margin is what happens at the edge. So if you're talking about a cost function c of x, and you want to know what happens if you increase or decrease, usually increase, but increase or decrease production slightly, what will happen to your costs? And the marginal cost is calculated using c prime of x. So if I'm making 100 widgets and I want to make 101, I can do a marginal cost. C prime of 100 will tell me what happens when I slightly increase. And then revenue, marginal revenue, same thing. R of x and R prime of x. How does our revenue change? So you can find out whether it's worthwhile. What do costs do if I slightly increase? What does revenue do if I slightly increase? Tangent lines. Tangent lines, remember, y minus y1 equals m times x minus x1. M is the slope, and x1 comma y1 is any point on the graph. Very easy way to write the equation of a line. And so how does that apply to a tangent line? Well, we know slope is f prime at that point. The x value is a at that point, and the y value is the value of the function at a. And what's the difference between a tangent line and a normal line? Well, a normal line is perpendicular to a tangent, so the slope becomes -1 over f prime of a. If you're going through the same point, then a and f of a do not change. All right, that is chapter 3. Congratulations. If there's anything on there that you're still a little fuzzy on how to use it, I recommend you go back through your notes, go back through the book, rewatch videos in that section. And thanks for watching. Hope you learned something.